So now in this video I'm going to do another circuit modification video. I have a 555 timer here wired in Astable mode. That's 555. Not sure if I accidentally mumbled another 5. But what it's doing is turning an LED on and off. It's an LED module though. It needs quite a bit of current, pretty close to the maximum current of the 555 timer, and also for the 2N 3904 transistor. So I have a 2N2222 transistor. It can switch more current, a lot more current. So we are going to use that. It can switch up to about 600 milliamps current. We're getting down to below a third of that, so that's probably like a decent amount. Now, I think we're going to have to slow this down a little bit to get fade. I'm assuming that at this speed, the 555 the LED, I mean, will look like it's just on constantly, even if it gets a little bit dimmer. So I suspect this is 5 times as much as that one. It's 4.7, 470 microfarad, I mean, capacitor versus 100 microfarad capacitor. This is also a 100 microfarad capacitor. Interestingly enough, quite a bit smaller. I was having a little trouble finding in my baggie of used capacitors another 100 microfarad capacitor, because this one is like the size of one like half as much, but it does say 100 microfarad, 50 volts. That also says 50 volts. I thought maybe it would be a lower voltage. So first off, the output goes high and low, so it will discharge the capacitor. So we have to modify this with a rectifier diode. So I'll zoom in and we'll take a look at that. The resistor was going from the output to the base of the transistor to turn it on and off. So we are going to put the diode there so that current can flow in one direction only. It will let the capacitor charge, but not discharge. And then I'll plug this real quick, and we'll put the resistor now to the capacitor instead of the output, and also to the middle pin of the 2N2222, which is the base. As always, check the data sheet for pin layouts and maximum currents and stuff. Okay, so we'll zoom in, and it kind of looked like it was going in the same spot as the jumper until you move it there. Be aware that the camera, sometimes it might look like it's going into a spot where it's not supposed to. Last video, I had a blue jumper going to the LED module here, and so you know, it's coming from the positive supply though, so I figured probably red would work better. I just grabbed a jumper without even thinking about that. Now we'll put the LED back. So we should have the same circuit here. The rectifier diode will drop a little bit of voltage from the resistor. They're limiting the current a little bit, but again, that's what the transistor is for. You just need a certain amount of current going through it to turn the transistor on fully. And I'm assuming we are meeting that right now. We could measure it to make sure, but this should be making such little difference. I'm not going to worry about that right now. So let's try the 100 microfarad capacitor as we have it here. And so this is asking for quite a bit of current in relationship to when I'm just switching a little indicator LED. I swapped it out here. So this might actually discharge so quick that it doesn't really look like it's keeping the LED lit, but there, okay, we did have a little bit of fade. So this actually, if you like this effect, there you go. We already have the effect you want. But again, that's 100 microfarad capacitor. This is a 470 microfarad capacitor. So the output can be high and low for just as long. So the LED is going to be lit up for the same amount of time, basically fully. The fade will have a lot more time, so we should fade probably completely off. So output's high, and so looks like there we go, we got that fade. So yeah, if that's what you want more, where the light's on for like quite a while, it fades off completely, and then it will be completely if you don't see any current on there. And yeah, so that might just be background current for, you know, like charging the capacitor or something. There you can see that current's gone basically to zero right there. So we know the LED module turned off completely. if there's not like 50 milliamps of current or something going through it. It doesn't have enough voltage anymore to get it to conduct at all. I've gone over that in recent videos with that module. So yeah, any case, this is just a quick modifying the circuit video. I'm not going to make a schematic. To be honest, this video might make like $1 to $3 or something. You know, it might make quite a bit more than that. But the majority of my videos will make like $1 to $3 over a year. And so I'm not going to make a brand new schematic for all of them. You know, if there's like a lot of interest in what I just did here, then I'll probably make like a schematic or whatever, just to be honest with you. But I think I'm going to do a lot more of these, just quickly modifying a circuit, because that's what you should be doing when you're studying circuits. Not so much finding the perfect circuit for what you're going to use, just a circuit that demonstrates the basic principles that you need to get your circuit working, and then you make the changes as needed to do so. Again, when I just had the little LED, I could use a transistor that could handle less current. It may not even give us a problem in this one, because it can handle up to 200 milliamps of current. But again, that will probably be like enough to shorten its life or something. You shouldn't exceed, or you shouldn't go up to the maximum of the properties. Other than like brief periods of time are probably okay. But you should try to stay like halfway most of the time or less. And we needed the diode there because the output does go low, which would instantly discharge the capacitor if we had it to the output, which is kind of what you need. So the diode basically lets us connect to the output, but only when the current is charging the capacitor. The only way the capacitor can discharge is through the resistor right there. As its voltage goes down, the LED will get dimmer. The transistor will stop conducting as well. But current cannot go back because we have that rectifier out. So yeah, in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.